Thank you for your kind introduction. I'm Seok-Gang from Busan, Korea. It is a great honor for me to be here, and sincerely congratulations, successful the 13th TOTS. Today, I would like to talk about the efficiency of a radiation shielding sheet to reduce radiation exposure during CM fluoroscopy. I'd like to thank everyone who has kindly welcomed me as a traveling fellow. I visited Buyinpong Hospital and Ramadivo Hospital. Thanks again, all of doctors. Let's get back to today's topic. In the last century, the radiation device for diagnosis and surgery were developed, not only in the field of orthopedics, but also in various medical fields. However, development of a radiation device causes a large amount of radiation exposure to medical workers and patients. There are many studies on correlation between radiation cancer. Among them, this study is a representative study related to female orthopedic surgeons. Trauma surgeons are exposed to a lot of radiation, and as a result, the incidence of overall cancer, especially breast cancer, is 2 or 3 times higher. There are 2 biological effects of radiation exposure. First is deterministic, and second is a stochastic effect. Deterministic, non-stochastic effect is a dose-dependent severity, a very high dose radiation, but second stochastic effect correlates with increasing radiation exposure over a long period of time. So thus more applicable to orthopedic surgeon. These are referred to as stochastic effects and are not related to radiation dose, but to higher dose accumulation, increasing probability of this effect occurring. That is why as a reasonable achievable principle, called the ALA principle, has been emphasized. In this study, the shielding effect of non-radial radiation shielding sheet, which was designed for minimizing the exposure of medical staff and patient, was evaluated using a phantom model. The authors evaluate the radiation protection performance of the sheet using 2 possible scenarios in which the sheet was located on the X-ray tube and under the phantom model. Radiation shielding sheet, the author adopted a non-radial radiation shielding sheet was with high flexibility and low weight. It mainly consists of tungsten and bismuth. CM fluoroscope unit was used irradiate phantom model with a fixed condition of 64 kilovolt and 1.5 milliampere. The phantom was located such that the center of sternum coincided with the center of the X-ray beam. The equivalent dose values was measured using a gamma survey meter in millisievert per hour. The 3 scenarios, first without fiber. Fiber means a seat. Without seat, sit on the X-ray tube, sit under the phantom. Each scenario, 3 directions. We investigated separate, caudal, and operation direction. And the distances from the beam center 36 and 90 cm. To determine the difference in image quality by seat, the contrast to noise ratio was measured. At center radiation dose, this is the result. At center, radiation dose was 4.9 without seat, 1.6 on tube, and 1.5 on the phantom. At 30 cm distance, the average was about 1 point and 0.2 and 0.3 respectively. This figure shows the loss reduction curve in each direction of without seat, S tube, and S phantom. In the area within 30 cm radius from the beam center, the measured dose were reduced by 30% and 67% on the average in S tube and S phantom. In case of a longer 60 cm radius from the beam center, the measured dose was reduced by 70% and 61% on average in S tube and S phantom. However, in operation direction, noticeably high dose value was observed at the center to detector distance of 30 cm in S phantom. It means S tube is most effective. In S tube and S phantom, all those values measured at position more than 60 cm away from the beam center were less than 0.1 millisievert. As you can see from the pictures, it is difficult to detect the difference when observing with the eyes. The Alala principle is very important. Only 69 trainers were aware of Alala principle, but other papers said that only 18% of trains had read any literature on radiation safety, and only 24% had a thyroid shield. And moreover, most or 99% were unaware of the amount of radiation a patient was exposed to during fluoroscopy. This JBS review paper suggests several ways to reduce the radiation exposure. When using a directional radiation technique, the intensifier should be on the same side as a surgeon. In our study also predicted that operators would be exposed to significantly more scattered X-rays if you stand opposite side X-ray tube. RID is widely used as a radiation shielding agent due to its low cost. However, it's a harmful effect on human body, and due to RID being heavy, 25% users report a problem with the other joint. Due to RID's heaviness and toxicity to human body, so it has recently been replaced with eco-friendly shielding materials, especially barium, boron, tin, bismuth, and tungsten. The density of tungsten is higher than that RID. It has a higher electronic density than RID when it's the same size. Here is a picture of the actual surgery using a seat. Some of the intensity of electricity increases when the seat is used, but we can reduce the intensity. It is difficult to tell the differences between the two photos taken in same condition. The authors confirmed the high radiation shielding performance of a lead-free tungsten-based sheet during CM fluoroscopy. The most beneficial scenario is in which the sheet can be utilized was also verified. The radiation shielding sheet was placed on the X-ray tube. The radiation exposure was reduced by 72% on average. The authors expect that this study could provide useful information and insight when the operation design the overall surgical scenario using CM fluoroscopic system. Thank you for your attention.